In this video we're going to be talking about roots. Alright, so we're starting with what we call square roots. Right, so you need to know that a square root of a number a is any number that yields a when squared. So that's what we call a square root. Any number that yields a when squared is the square root of a. For example, we know that 2 squared is equal to 4, and since 2 squared is equal to 4, that means that therefore the square root of 4 is 2. 2 is the square root of 4 because 2 yields 4 when squared according to our definition. Okay, so we write this as the square root of 4 is 2, so we use that square root sign. So we also have the square root of 9, which is 3. Why? Because 3 squared is 9. Right, so we are saying that the square root of 9 is the number 3, which yields 9 when squared. As simple as that. So we also know the square root of 16 is 4, because 4 squared gives us 16. We also know that the square root of 49 is 7, because 7 squared is 49. And we also have square roots like the square root of 2, which gives us 1.4142 to 4 decimal places. It continues to go to infinity. But you see, for the square root of 2, you can see that the square root is not a whole number, it's a decimal. And for such square roots, you may need a calculator or some tables in order for you to get the value of the square root of such numbers as 2. But for the other ones, like the ones I gave you in the examples, square root of 9, square root of 16, square root of 49, since they are square roots of perfect squares, therefore we get whole numbers for the square roots. A perfect square will give us a whole number square root. You always need to know that. So that means that 9, 16 and 49 are perfect squares. But for 2 is not a perfect square, so the whole number, so the square root will not come out a whole number. It will come out like in this case we've got a decimal 1.4142. This has been rounded to 4 decimal places. We also deal with cube roots. Right, so a cube root of a number a, right, is any number that yields a when cubed. For example, if we find the cube of 2, that is 2 cubed, we know that we get 8, because 2 cubed, that's 2 times 2 times 2, so that will give us 8. So we write this, we can write the cube root of 8 as cube root of 8 is equal to 2, right? The cube root of 8 is equal to 2, like that. So we know that the cube root of 27 is 3, because 3 cubed gives us 27. So that means the cube root of 27 is 3. The cube root of 64 is 4, because 4 cubed gives us 64. We also have the cube root of 1000, which is 10. Why? Because 10 cubed is 1000. So there are many values for cube roots for all the numbers. Sometimes it also can be necessary for you to use a calculator in order for you to find the cube roots of certain numbers which are not perfect cubes. Okay, so that is square roots and cube roots, but we also have other roots that we deal with, right? So also deal with other roots which are not square roots or cube roots. So let's talk about other roots just for a little while. Okay, so other roots. Sometimes you can find, or you can be required to find, like in this case, the fourth root of 16. Now the fourth root of 16 is 2, because 2 raised to the power of 4 is 16. So we are saying that for the fourth root we are looking for the number which when raised to the power of 4 will give us 16, and in our case that's 2. So the fourth root of 16 is 2. Another example, like the fifth root of 243 is 3. So we know that, because we know that 3 raised to the power of 5 will give us 243. We also know the sixth root of, say, of a million is 10, simply because 10 raised to the power of 6 gives us a million. So all these are other roots we've got. We can find as many roots as we want on any number. It's possible. We can have fourth root, fifth root, sixth root, all the way up. So this is our lesson on roots. I'm going to be giving you some examples, some workings, some problems that you have to solve that involves roots.